Hey friends, it's Michael, and today we're going to be building a very basic PERN full-stack application completely from scratch. The technologies we're going to use for this are React with React Router DOM on our front end, Express built on top of Node for our back end, along with Sequelize, an ORM to communicate with our database. Our database will be in PostgreSQL. Now before we get started, there are a few requirements. You need Node installed on your computer, as well as a text editor of some kind. I will be using VS Code in the video. To follow along completely, you should also have a GitHub account. In my opinion, developing a full stack application has two major roadblocks. The first is making a connection between your front end, your server, and your database. And the second is getting a deployed, hosted version of your code out into the world. The objective of this video is to cover those 2 points so that you can use this project as a launchpad for your own amazing full stack application. So without further ado, let's dive right in.
Let's start by taking a look at the plan for our application. Now this is intentionally simple because this whole project is really meant to get you started. In our front end, we're going to have 2 components. App.js will be our parent or core component. And as a child, we will have library at the /library route in React Router DOM. This component will be in charge of rendering all of the books in our library. In our Express server, we will have one controller for our books endpoints. And in that controller, we will have one endpoint, a get for the /API/books route. In our database, we will have one books table with 4 columns. Book ID will be our primary key. We can set this up to auto increment just to make our lives easier. Name is going to be character varying set to 255 precision. Author will have the same data type. Year published will be a small int, just so we can save ourselves from timestamps and things like that. The way that this is going to work is our React front end is going to communicate with our Express server via JavaScript fetch requests. When the server receives a fetch request to the /API/books endpoint, it will then use our ORM Sequelize to communicate with our database. The database should return all of the books in our books table, hand it back to our server, which will then return it to our front end to be rendered. So that's how it's going to look from front to back and back to front. Next, let's initialize our project with GitHub. In your browser, head to github.com/new, making sure you're logged in. And we'll have to think of a repository name for this project. How about library? Yeah, not super original, but hey, gets the job done. Click Create Repository down at the bottom. And we are greeted with some handy commands to create a new repository on the command line. Go ahead and copy these commands with a button on the top right. And open up a terminal on your computer. Navigate to where you want to keep this project within your local files. And let's make a new folder for it. Now, the folder name does need to be all lowercase. I'm going to call it library. CD into that new folder. And paste all of the commands that you just copied from GitHub. Now, if we refresh on our browser, we should be able to see our readme.md with our project name in it. Nice. Now let's go ahead and get some boilerplate code into our project so we don't have to start completely from scratch. Open your terminal back up. And we'll get a create React app going with the command npx create React app and direct it to the current folder with the period. Now this can take some time, so just give it a moment. Once it's finished up, we do have a few more npm packages to install. So let's go ahead and do that now with npm I and our packages listed out between spaces. So we're going to need cores.env, express, pg, pghstore, Sequelize, and React Router DOM. Hit enter and those should install. Perfect. Now go ahead and open up the project in VS Code using the code period command. We are going to want to reorganize this folder structure a little bit, mainly just adding a new folder called server. We will also need a .env file on our root level, and let's make sure .env is included in the gitignore. Now that we're in VS Code, let's go ahead and open up a terminal here and navigate to our server directory. Here we're going to use the Sequelize CLI to initialize a Sequelize project. If you don't have the Sequelize CLI installed, simply run npm i-g for global install Sequelize-CLI. If you prefer not to globally install it, you can also run the command npx sequelize-CLI in place of all of the Sequelize commands I'm running here and in the future. So the command to initialize an empty Sequelize project with some great boilerplate code is sequelize init. Hit enter. And if you open up our server folder now, you should see some new folders that were automatically generated by that command. Config, migrations, models, and seeders. Let's also go ahead and create a new file in the server folder. Call it server.js. This is going to be our main entry point and the core of our Express server. Additionally, let's create a folder for our controller. So new folder at the server level and call it controllers. We've done a pretty good job of setting up our app so far with some boilerplate code. So let's make sure to add and commit and push our changes to GitHub. Make sure in the root folder of the project library. And if we refresh our GitHub page now, we should see those changes. Perfect. While we're back in the browser, let's go ahead and prepare our deployed database. I recommend using Supabase, so head to app.supabase.com and create an account if you don't already have one. Once you've done that, go to your dashboard and click the New Project button. Make sure to give it a good name, library. Make sure you remember this password or copy it using the button on the right once you're done typing it. Now that you've done that, click Create New Project, and that can be setting up in the background while we work on our application some more. Open up VS Code again, and let's change the config.json to a JS file. Now, the reason we're doing this is so we can use our env file for our secrets, our database password, hostname, all that information. Since this is now a JS file, we need to export this object. So give ourselves a little bit of room. And module.exports this object. Now this is still JSON, so we should remove the double quotes from our keys here. Make sure it didn't mess anything up. Should look something like this. And let's change all these values to be env values. We'll call username process.env.db username. Password will be process.env.db password. Database will be process.env.db name. Host will be process.env.db host. And we can change the dialect to Postgres, since that's the database flavor that we will be working with. If you want to see the logs in your terminal as commands come through, you can also add the logging true option here. Can be handy. Additionally, if you want your port to run on a different than the default, that would go here as well, or in any of these options blocks. Now to actually read our .env file, we need to require the .env package up top with require.env.config. There's one other thing we need to do now that we've changed our JSON file to a JS file, and that's in the index.js of our models. So head there, and on line 8, you're going to see config.json. Just go ahead and change that to JS. Let's head to our env file and actually set up these variables. First will be db username. Then we want db password. db name. And db host. Our Supabase database should be up by now, so let's double check on that. Okay, looks good. Here from your dashboard, click the gear icon on the left side of the nav bar and go to the database project settings. Here's where we can copy all the information from the connection info into our environment variables file. So let's get the host. Database name is Postgres. The username should also be Postgres. And the password is that password you should have remembered from earlier. All right, looking good. Next, let's utilize the Sequelize CLI again to help us generate a model. This is going to be very handy, save us a little bit of time coding. Down in your terminal, make sure you're cd'd into the server directory, since that's where we want our model, and run the command Sequelize model:generate. Let's give it a name argument. We'll call it book -- name book -- attributes. And now we put our columns and their data types separated by colons and commas. Start with book ID, integer, name, :string, author, :string, and year published, tiny int. Okay, I'm gonna pause this right here and give myself a little bit of advice from the future. At this step, I should have used a capitalized book for the name, and also used the small int instead of the tiny int data type for the release year. The reason for this is the model name just should be capitalized since it is a class, and also tiny int is not a valid data type in PostgreSQL, even though it is in Sequelize. So small int would have been a better one to use for this. And I do fix these issues later on, just would have saved me a little bit of extra time to do it right from the get-go. Let's hit enter and see what happens. Okay, as you can see, we have a new book.js model here in the models folder. We also got a migration for the model. These files are a good starting point, but we probably do want to edit them just to be a little bit more specific to our entity relationship diagram or table planning that we looked at earlier. So let's go to book.js, and we should go ahead and wrap all of these data types in objects. So we have more options for setting up our columns. Give ourselves a bit of room. And each of these data types should have the type key now as part of this object. For the book ID, we need to set it as our primary key with the primary key true option. And we also want this to auto increment, so let's use auto increment true here as well. For the rest of these, they're pretty important data to have about a book. So let's go ahead and add allow null false for all of them. As a second argument of this init function, we have our second options object. Let's change the model name to be uppercased and add a new key and value for the table name, lowercase books plural. And finally, let's set timestamps to false so we don't get any extra columns along with our table once this is migrated. Since we decided to call it uppercase book, let's also change that here on line 40, up here on line 6, and right here on line 16. Now let's take a look at our migration file and make sure that's going to apply correctly as well. Looks like we have an extra ID column that we don't want. However, we do want this information for book ID, so what we can do is just copy or cut this out of here, apply it to book ID, and just delete the ID object. We don't want the create at or updated at columns, since we turned off the timestamps in our model itself. These three remaining columns should have allow null false. One more thing we need to change is tinyInt is actually not a valid data type for Postgres. So here under the year published block in the migration file, let's change that to small int, since that should work for us. Now that we've created our model and our migration file, it's time to work on our server.js. Let's head there and begin setting up our Express server. We'll have a dependencies block at the top with const express equals require express, const app equals express invoked, const, and here we do structure Sequelize equals require Sequelize. We will eventually want path as well. So let's add that here while we're already at it. Const path equals require path. And we need to set up our cores middleware as well. So const cores equals require cores. Now let's move on to the configuration and middleware of our Express server. First, very important, we need to use .env. So let's call require .env.config. We'll set up cores as a middleware with app.useCores. We also want to use express.json. And we'll also set up app.useExpress.url encoded, pass in extended :false as an object to that URL encoded method. Now let's actually start our server with app.listen. We can have the port specified in our env, or we can just set it up right here. Now the create React app dev server does run on 3000, so we want to pick something different. Any port that's open on your computer should be okay. Let's try 4005. And here it's pretty standard practice to just have a console log so that we know when our server is actually running. At this point, we should be able to run this in the terminal with node server.js. And there we go. Looks like it's running. Now that we have a bare bones server set up, let's work on applying our migration to a Supabase database. Right now, our config.js unfortunately can't read our .env file because our .env file is at a different level than our server folder. To fix this, let's make a .sequelize.rc file at the root directory, the same level as the .env. Up at the top, let's get path with const path equals require path. Let's also require .env.config again. And now we need to export an object. The first key is config. And we do wrap these in strings. And we call path.resolve with the path to our config file. So this will be /server/config. And the second argument is our actual file. So this is config.js. Let's also set our models path with another path.resolve./server, and as a second argument, models. Now we need seeder's path with again path.resolve/server as the first argument and seeder's as the second. Migrations path is again path.resolve./server and then migrations as a second argument. Now that we have the Sequelize RC file, let's finally attempt to apply this migration to our Supabase database. Make sure you're in a new terminal. And let's cd out to the main directory. Here we can run Sequelize db:/migrate and hit enter. Okay, since we have logging, we do see a fair amount of output, but we can see it says create book migrated. Now to double check this, let's go back to our database on supabase.com and click the table editor button over on the left side navbar. And there we go, we now see books as one of our tables, which is exactly what we want. This table's looking pretty terribly empty though. So let's insert some dummy data in here with the Sequelize seeder. Go ahead and open up your VS Code again. And in the terminal at the root directory, let's go ahead and run Sequelize seed:generate --name books and hit enter. Okay, as you can see, we have a new seeders file here, which is exactly what we want. In the up for the seeder, let's go ahead and delete this comment. And we want to await query interface .bulk insert. We're going to insert into books. And here we have an array of objects as the second argument. So let's add a few objects here. I think 4 should be okay. In each of these objects, we will need to fill out the columns minus the ID since that's auto-incrementing. Let's hit enter. And we'll have name. We can do The Hobbit. Author, J.R.R. Tolkien. And year published, 1937. Okay, we probably want to switch these up a bit just to have a little more variety than 4 Hobbit books in our database. So I'm going to go in here and change these books to be different dummy data. Okay, we got some useful dummy data in there now. For the down, we need to make sure to delete all this data if we ever want to revert this. So let's await query interface .bulk delete from books. Pass a null as a second argument and an empty object as a third argument. That should take care of clearing that out for us. All right, let's see if we can get this data into our Supabase database by running Sequelize db:/seed:all. And it looks like it ran. We can double check by refreshing our page here on supabase.com. Amazing. Now we have 4 dummy data books inside of our database. Now let's move on to making the controller for our server. Here in the controllers folder, let's make a new file. Call it bookcontroller.js. Or a books controller, since our endpoints will be under books. Up at the top of this file, let's go ahead and require express.router as books. We also need our DB instance from our models index. So const DB equals require models. And we should path this directly to the models folder. So it'll be //models. Now let's destructure our actual model off of the DB with const book equals DB. Now let's create our endpoint. This will be for get all books. And we'll say books.get with just a /. Let's set up an async. Rec res for request and response. And get your arrow function. Now let's have a try catch block to handle errors appropriately. I'll go ahead and set up the skeleton here. In the try section, we're going to await book.findAll. So const found books equals await book.findAll. And let's give back a status with res.status 200 and then JSON the found books. Now in our catch, we need to send back a res.status 500. And we don't really want to send the error message back in most cases, so let's send a message instead of server error. We can always look at our server logs if we need to know what exactly went wrong. To make sure we get a log, we will console.log the error. Finally, in this file, at the bottom, we need to export this with module.exports equals books. Now let's go to our server.js and actually use this controller. Underneath the configuration and middleware section, let's set up a controllers section and get our controller as books controller with const books controller equals require controllers books controller. Underneath that, we'll set up app.use /API /books with books controller as a second argument. Again, this is very important to have the /API before our books because eventually this Express server will be in charge of hosting our static React code. And so we need to make sure our backend routes and our front-end routes don't get confused. A very easy way to do this is just to prepend the server routes with /API. Now in our terminal, let's go ahead and cd out to our main directory so we can use the .env there and run node server /server.js. Looks like it's up. To make sure everything's working correctly, let's go ahead and use Postman to test this new endpoint. We're going to be making a GET request to http://localhost 4005 /API /books. And there we have it. All of the books in our Supabase database are now able to be accessed via URL request through the Express server endpoint that we have set up. So this is a big moment. Go ahead and congratulate yourself if you've gotten this far. And the only thing left to do now is to create our front end and tie it into our back end using fetch requests. Let's go ahead and close Postman. We'll be spending most of the rest of our time here in the source folder of our React app. In our source folder, let's start cleaning out our create React app boilerplate code. I'm going to go ahead and delete this readme.md and rename this to just readme.md. It is the old one, but that's the one I want. We can also delete the logo.svg. And in our app.js, make sure to remove the import logo line. We can keep the app.css for now in case you want to do some styling in that file. And let's delete everything between the div here. Now let's start up our React dev server with the command npm start. Looks like it fired up. I'm going to go ahead and split my screen between the VS Code window and our browser window so we can see as we develop. I'm going to start developing on app.js by using React Router DOM to set up a simple navbar and our first component under a route. Up at the top, we're going to want to import browser router as router, comma link, comma route, comma routes from React Router DOM. Inside of our div class name app, let's have a header element along with a nested UL and two LIs for now. The first LI will be our home route, and the second LI will be our library route. Now this text content should be wrapped in our React Router DOM link. And of course, we need the to prop on each of these with the string to where the path should go. And finally, to get this working, we need to wrap this whole thing in the React Router DOM router. At this point, we should see our two links up at the top of our browser. And they will be functional, although they won't show any components yet. Let's stub out our library component. First, in the source folder, we'll make a new folder called components. And make a new file in that folder called library.jsx. If we're going the JSX route, we might as well rename app.js to JSX as well. Here in the library component, let's export default function library. We won't need props for now, so go ahead and leave the arguments empty. And let's return an h1 with the text library. Very simple stubbed component. Back to app. We will import this component up top from ./components/library. Now underneath our header in the return of our app component, let's create a main element and use the React Router DOM routes component routes should have two route components within it. The first one's path should be just /, and we'll leave the element empty for now, although we should technically go add a home component at some point for this path. The second route should have a path to library, and the element should be our library component. At this point, we should be able to click back and forth between the two links on our browser and see the library component pop up when we click library along with the / library route in the URL bar. Next, let's go to library.js and fill out the functionality we need to actually retrieve the information from our server. First, up at the top, let's import useState and useEffect from React. Above the return, we'll set up our state with const books and set books equal to useState with an empty array as the initial value. Now let's set up our useEffect and call our fetchData function. So we're going to set up our fetchData with async const response We will await fetch http://localhost 4005/API/books. Now this is the same URL that we checked with our Postman, so it should work for us. Now let's get the JSON version of this with const JSON equals await response.json and set books to that JSON response. Now to prevent our use effect from running over and over with an infinite loop, let's add a dependency array as a second argument, just an empty dependency array. And now we can call fetch data right underneath the function after we've defined it. Now let's attempt to render the data returned from our server into our React app. In the return, we'll first wrap this h1 with a parent div as per React rules. And let's set up another UL here. Inside of the UL, we're going to map over books. So open up a curly brace pair and call books.map. Map will take in a callback function with book and index as its parameters. We want to return an li with the key set to index. That will need to be in curly braces. Close off that li. Let's have a div with our curly brace book.name. Another div with our book.author. And another curly brace with our book.year published. There we go. The styling is not great on this, admittedly. We can at least get some space between these elements by calling the style prop and giving it a padding bottom of 25 pixels. A little bit nicer. So we've just passed another huge moment where we are successfully able to retrieve information from our server, which is then able to retrieve information from our database, and goes all the way back to the front end where we can render a list of this information. So round of applause for yourself, great job. Now would be another great time to add and commit our work. We do have two different servers open right now. One is our node server, and one is our React development server. When you're working on your local host version of the application through normal development, this will often be the case. You'll have these two different servers open in your terminal. So we will need a third terminal to add and commit our work. Let's go ahead and push it to GitHub as well. All right, now we need to focus on hosting our node server and in turn allowing our node server to give us the static files of our React app. First in the terminal, let's run npm run build. What this does is minify and optimize our React app down into a build folder with a bunch of static files. Now that's done, we can check it out. And this is basically our whole React app just as a minified version. Now we need to instruct our node server to serve up this build folder. So let's go back to server.js in our server folder. And underneath the configuration middleware section, let's set up a new line with app.use express.static. And we'll use the path const that we set up on line 5. Path.join _dir name as the first argument and // build as the second argument. So we want to point to the build folder, one layer out into build. Finally, at the bottom of the file, underneath the listen, we'll set up a catch-all route with app.get star as the first argument, rec res, arrow function. And what we want to do is res.sendFile. We're going to use the path.join again. Double underscore dir name, so our current directory, with /build / index.html. So we want to point to this index.html file right here. We do still have our React app server running on localhost 3000, but what this has enabled is our React app to also run on 4005. So to test this, let's restart our node server and change this URL in the browser to be 4005. And it should function exactly the same. This is a good sign. It means that our server, which is running on 4005, is now able to host the build static folder for our React app. Keep in mind, you will have to run the build process every time there's a new improvement or addition to your React app. For that reason, I recommend still developing on the localhost 3000 server, just because that's always going to be up to date based off of the React server. It's finally time to try and deploy our node server now that it's in charge of hosting the build folder for our React app. The tool I recommend for this currently is Render. So go ahead and go to render.com in your browser. After you've signed up for a Render account, it should take you to the dashboard, dashboard.render.com. What we're looking for here is the web services. So click on New Web Service. And the way that Render works is it connects directly to your repositories on GitHub. Now we do need to grant access to this repository through Render. So find where you can configure this, go to your profile, and find your repository. Make sure to give it access to the repository in question, and hit save. Okay, now you should see it somewhere in this list, and hit connect. We'll need to give it a name. I'm going to call it library demo app. Select a region that's relatively close to yourself, and select a branch to build from. At this point, we only have one branch. Although it is a good idea to have multiple branches, you probably want to build off of your main in most cases. Leave root directory alone. The environment is going to be node. Our build command should be npm install and npm run build. And our start command should be node server / server.js. We should also turn auto deploy to no. Otherwise, this will soak up a lot of our free tier resources as we push changes to our repo. Scroll down to the bottom and make sure to start it. And we might need to wait a second for this to spin up. While it's spinning up, let's go ahead and fill out our environment variables in the environment section on the left. And we basically want everything that we had in our project env file. Click Save Changes, and again, wait for the build to finish. The first time you build your app on Render, there is a chance that it will take a very long time or even fail. Unfortunately, this is because the free tier of Render has very limited resources as far as CPU and RAM goes. So if it fails, I recommend just keep on manually deploying it from the latest commit until it succeeds. It should eventually succeed because it does build a cache each time it attempts a build. And unfortunately, even when it succeeds, there are some times it doesn't actually build the project correctly. So if you get some errors on the front end that say cannot get /, or if you check the console and you see 503 or 502 errors, I would recommend just keep building it over and over until it works. What you're looking for is the ability to click on this link right here near the top and see your React app like I see right here. We should be able to go to our library route and see our books. And now we have proven that we have a fully functioning hosted full stack application. So our node server is hosted on render. It's in charge of serving up our static React files. And then our server is also handling all the connections to our Supabase through Sequelize. And now that it's deployed and hosted, we should be able to hand this link to anyone, and they should be able to access the application from whichever device, as long as they have this link, which is really, really cool. So I think we all deserve a really big round of applause for ourselves again. We have done it. This is quite the feat, and good job for following along and sticking with it. So what's next? Obviously, this is a very bare bones application and could use a lot of improvement. Now, I don't recommend developing off of this environment. What you want to be doing is continuing adding features to your application, whether it's more API endpoints, more components on the front end, making new models for more tables, things like that. Do that all on your local host with your two servers open, one being your node server and one being your React server. When you feel like you've gotten to the point where you have a better version of the app with newer features and more additions, what you want to do is push to the main branch and then go into your dashboard on render and manually deploy the application again. This will run the build process and the npm install process as well to make sure that it covers any new packages. And yeah, you cross your fingers, hope it goes. It should, after the first time it works, it should deploy and build successfully most times after that. But now you are well on your way to creating your own amazing full stack application, and it's something that you can show off to your friends and family, and they'll be pretty impressed that you were able to pull this off. Maybe if you style it a little bit better than I did, but hey, we didn't really have time for that here.
There are many great free or cheap options for hosting a project like this. So in the future, if you come across a better combination than what we used here, Supabase and Render, feel free to try it out. The process is largely going to be the same as what I've outlined in this video. Keep in mind, this project is far from being complete, but hopefully it serves as a really good starting point for your own application. Thanks again for watching. If you have any questions or issues, make sure to leave a comment. And if this video helped you out in any way, a like would be greatly appreciated. Until next time, keep that coding brain pumping.